Hi everyone, I am Dr. K. Meena, Assistant Professor and Head, Department of Mathematics, Arulmigu Palani Andavar Arts College for Women, Palani, Dindikkal District, Tamil Nadu, India. I am going to tell about applications of differential calculus. Before we understand the uses of differential calculus in our daily life, first understand what is differential calculus. It is the mathematical study of continuous change. In mathematics, differential calculus is subfield of calculus concerned with the study of the rates at which quantity change. Who discovered calculus? In the middle of the 17th century, calculus was developed independently by Isaac Newton and Leibniz. Before looking at this topic, let's look at some of the definitions we need. First, what is function? A function is defined as a relation from a set of input to the set of outputs, in which each input is exactly associated with one output. The function is represented by y equal to f of x. X is independent variable, y is dependent variable. Next, what is rate of change? It is a rate that describes how one quantity change in relation to another quantity. It is of two types. One is average rate of change, another one is instantaneous rate of change. I have to explain the average rate of change and instantaneous rate of change using the slope of the secant line and slope of the tangent line. What is slope? We know that slope means tan theta equal to rise by rn. We have 2 points x1 y1 and x2 y2. What is slope? M equal to y2 minus y1 by x2 minus x1. What is secant line? It is a line passing through 2 points of a curve. What is tangent line? A line that just touch a curve at a point. What is the slope of the secant line formula? From the figure, the secant line PQ. So the point P is x comma f of x, Q is x plus delta x comma f of x plus delta x. Slope tan theta equal to opposite side by adjacent side. Change in y by change in x. That is delta y by delta x. Therefore, the slope of the secant line PQ means delta y by delta x must be equal to f of x plus delta x minus f of x by delta x. Let me illustrate with an example. You are going from one place to another place in car. The path you take in the car may be evenly spaced or even bumpy. When we draw a graph with a measure of the time and distance, we get the curve y equal to f of x. Suppose distance is 200 km and traveling time 5 hours. What is your speed? Speed formula, distance travelled by time taken. Using the slope of the secant formula, change in distance by change in time, delta d by delta t. So 200 minus 0 by 5 minus 0. So 40 kilometers per hour. This is the average speed. This is an example of average rate of change. You need 2 points to find speed. Our formula gives us average speed. So next, what's speed at the time of collision or speed at an instant or instantaneous speed? Speed at t equal to 5, suppose. So change in distance by change in time, 0 by 0. So meaningless. You just have 1 point, 5 comma 200. So and hence can't use the formula. So choose some point as second point. It is extremely close to point where you need to find speed. For example, for speed at t equal to 5, choose t equal to 4.992. Okay. For find average speed over this small interval. Change in distance by 0.001, that is delta d by delta t. Next, choose interval to be extremely close to 0 but not 0. So speed at t equal to 5, limit delta t tends to 0, delta d by delta t. This is the speed of the time of collision. Also, this is an example of instantaneous rate of change. From this also known as the slope of the tangent at a point. From the figure, when the secant line PQ is moved to right, the point Q approaches the point P, the value of delta x becomes very, very small. Delta x becomes smaller and smaller. The point Q approaches P and the line, the secant line PQ approaches a line called tangent to the curve at P. Therefore, the slope of the tangent line at P is equal to limit delta x tends to 0, delta y by delta x. Therefore, the slope of the tangent is called instantaneous rate of change because it represents a rate at a point, not between 2 points. This is also known as derivative of y with respect to x. So, derivative means dy by dx, that is limit delta x tends to 0, delta y by delta x. Therefore, dy by dx equal to change in y by for infinite decimal change in x. So, take y equal to x square. What is dy by dx? Put the formula dy by dx equal to limit delta x tends to 0, f of x plus delta x minus f of x by delta x. So f of x plus delta x means x plus delta x the whole square minus f of x means x square divided by delta x. So after simplification we get 2x plus delta x. So delta x tends to 0, 2x plus delta x approach to 2x. Therefore dy by dx means 2x. Suppose you take y equal to x. What is dy by dx? 1. Okay. Y equal to constant, dy by dx is 0. So next, applications of differential calculus. Let's look at a few examples. We know that rate of change of position is velocity, and rate of change of velocity is acceleration, rate of change of momentum is force. The uses in climate and weather prediction. By using differential calculus equation, you can calculate the effects of changing weather conditions in the atmosphere by applying such variables as temperature, pressure changes. This helps meteorologists to predict the weather. In business, credit card payments, financial markets, etc. In chemistry, it is used to determine the rate of chemical reaction in components. In suspension bridges, it is used to determine the shape of the bridge cable when the total weight of the load, the cable and the roadway per horizontal foot is constant. In astronomy, it is used to calculate the rate at which position of moving bodies change over time to determine their orbits. In biology and medicine use calculus in unbelievable ways. In tumor growth, it is used to determine how fast a tumor is growing or shrinking and how many cells make up a tumor. In sports, differential calculus is to calculate pitch of ball. The differential calculus is used in lots of fields: physics, engineering, medicine, economics, biology, space exploration, statistics, and many more. Without calculus, architects and engineers could not build a safe structure. It is used to find optimal solution and predict the future. Therefore, the differential calculus is involved everywhere in human's life. We need to learn a lot about this. In addition, we must constantly innovate without stopping. We can do something infinitely many times and get a finite answer. Thank you.